41 light-years from Earth, there is a planet so hot that its surface is made of liquid rock. Temperatures reach 2,000 degrees Celsius, hot enough to melt iron. By every law of physics, this world should have no atmosphere at all. The heat and radiation pouring off its star should have burned any layer of gas away billions of years ago, leaving nothing but bare, blackened stone. But in 2026, the James Webb Space Telescope found something that shouldn't exist, and it's forcing scientists to rewrite what we thought we understood about how planets survive. This is 55 Cancri e, a planet nearly twice the size of Earth, orbiting a sun-like star in the constellation Cancer. It was first discovered in 2004, but for years, astronomers weren't even sure what kind of world they were looking at. Some believed it might be a giant diamond planet, its interior packed with crystallized carbon. Others thought it was simply a dead, scorched rock, stripped bare by centuries of radiation. It orbits its star in just 17 hours, so close that a single year on this planet passes faster than one day on Earth. If you stood on its surface and survived, you could watch an entire orbit complete before your next meal. Being this close to its star means 55 Cancri is blasted with radiation and heat thousands of times stronger than anything Earth ever receives from the sun. Under those conditions, physics says any atmosphere should be stripped away almost instantly, torn off and blown into space like smoke caught in a hurricane. For years, this is exactly what scientists expected to find when they finally got a clear look: a bare, molten rock with absolutely nothing surrounding it. That assumption is exactly what made the next discovery so shocking. Using its powerful infrared instruments, the James Webb Space Telescope observed 55 Cancri e again and again, watching closely as the planet passed behind its star. And the data revealed something nobody expected: a real atmosphere, thick enough to actually measure, wrapped around this molten world. It appears to be rich in gases like carbon dioxide and carbon monoxide, with signs pointing to hydrogen as well. Somehow, despite temperatures that would vaporize steel, this planet was holding on to a layer of air. Scientists who had spent years predicting a bare rock were suddenly looking at data that made no sense, until they started asking a different question. So where does this atmosphere come from if the heat above should be destroying it? Scientists now believe the answer isn't in the sky at all, it's beneath the surface. 55 Cancri e is thought to be covered by a vast, churning ocean of molten rock, kilometers deep. As this magma ocean churns and shifts, it constantly releases gases from deep inside the planet, venting them upward into the thin atmosphere above. In other words, the planet is replenishing its own air from below, even as the star tries to strip it away from above. It's not a fixed, stable layer of gas sitting quietly in place. It's a living, breathing exchange, a constant battle between a planet's molten interior and the emptiness of space. This discovery matters far beyond one strange, distant planet. Billions of years ago, Earth itself was a molten world, covered in oceans of lava, long before it cooled into the blue planet we know today. By studying 55 Cancri e, scientists are essentially watching a working model of early Earth, frozen in an earlier stage of its evolution, a rare window into our own planet's violent, fiery past. It also proves something scientists didn't think was possible: that rocky planets can hold on to atmospheres even in conditions of extreme heat and radiation. That single fact is reshaping how astronomers search for atmospheres, and potentially life, on other rocky worlds scattered across the galaxy. 55 Cancri e isn't alone either. Astronomers have now identified a small but growing family of lava worlds like it. Planets such as K2-141b and L9859d, each locked in tight, blistering orbits around their stars. Some of these worlds are thought to have global magma oceans covering their entire surface, not just one side. Studying this family of planets together is helping scientists understand a critical, previously invisible stage of a planet's life: the fiery, chaotic period between formation and the calm, cooled-down world we might one day call habitable. But not everything about 55 Cancri e adds up cleanly. Its atmosphere appears to change over time, sometimes thicker, sometimes almost undetectable, in ways scientists still can't fully explain. Some observations even hint that the planet might not have one single stable atmosphere at all, but a constantly shifting one, torn apart by radiation, then rebuilt again from the magma below, in an endless cycle that repeats again and again. Webb has given us the clearest look yet at this extraordinary world, but the full story of what's really happening on its surface is still being written, one observation at a time. A world of fire, somehow holding on to air it shouldn't be able to keep. 55 Cancri E is proof that the universe still knows how to surprise even the scientists who study it for a living. And this is only the beginning. The universe still holds far greater mysteries, hidden in the dark between the stars. And what scientists discover next could change everything we think we know about how planets, and maybe even life, begin. If this blew your mind, hit like, subscribe, and join us for the next discovery. Because out there, the universe is always watching back.